Okay, whenever you are factoring, you always want to factor out the common factors first. Okay, so just in general, always want to be checking for that. Okay, a difference of squares. We have our difference of squares formula, which is hopefully familiar. It looks like this. So this just means we've got, these are perfect squares, right? And then we've got a difference because we're subtracting them. And we don't talk about sum of squares much because a sum of squares is just not factorable. It's not very interesting because you can't do much with it, assuming that there's no common factor. Okay. All right. So looking at this one, first thing I would think, oh, I've got two terms and I'm factoring this polynomial. So I'm thinking maybe it's a difference of squares. But then I'm thinking, oh, nothing times itself equals 5, at least not an integer. But I haven't factored out a common factor first, right? 5 goes into both of these, so I'm going to factor out a 5 first. Okay, and now the part that's in the parentheses is a difference of squares because x times x equals x squared, right? And then, 3 times 3 would be 9. Y squared times y squared would be y to the fourth. So this is going to be 3y squared times 3y squared. It's also a perfect square, right? So we've got a difference of squares because, hey, that's a perfect square, and this is, and we're subtracting them. Okay, so that means we can use this this pattern. Now we still got the 5 out there. I see people just forget about that or say, oh, I divided both sides by 5. Well, no, you didn't, because it's an expression, not an equation, right? There's no left side to divide by 5, so the 5 is still part of it. But then this is going to be x plus 3y squared and x minus 3y squared. Okay, and you could always try multiplying it back together if you're not sure. If you FOIL this, the inner and outer are opposites, so they'll drop out, and you'll just end it with x squared minus 9y to the fourth. Okay, and this is completely factored. And check your final answer too to make sure there's no more common factors in there. Okay. Next up, x squared plus 25. Well, hey, these are perfect squares, but it's a sum of squares, and that's not factorable. So this, you could just, it's already factored. You could just leave it as it is, or you could say prime or not factorable, something like that. Okay. All right, let's factor this one. So I'm looking for a common factor. So I'm thinking, okay, these are both even numbers, so I know 2 goes into both of those. And let's see what happens when we factor out a 2. Okay, and then I'm thinking, does anything go into 4 and 25? Nope. So this is, I'm done with the common factors. But I've still got a difference of squares. 2x squared times itself would be 4x to the fourth, right? And then 5y to the fourth times 5y to the fourth would be 25y to the eighth. Okay, so yeah, these are both perfect squares, and it's a difference. So we can use that pattern again. 2x squared plus 5y to the fourth, and 2x squared minus 5y to the fourth. Okay. All right, next up, we're going to factor this completely. Oh, I've got 4 terms now all of a sudden. Okay, so I'm first thinking, is there a common factor? Is there anything? Well, the first 3 terms have x's, but the last one doesn't. And then these 3 all have, I could factor a 2 out, but I can't out of the x squared. So there's no common factor for all 4 terms. But when we've got 4 terms, a lot of times we can factor this by grouping. Okay, and so all that means is that we're going to make a group out of the first 2 terms. And you could shuffle these around, and sometimes that'll work. But the problems you're going to see, at least to begin with, just try putting them in groups, in a group of the first 2 and a group of the last 2, okay? And you want that plus sign to be in between the groups. We're not multiplying these groups, we're adding them together because we got a plus sign right there, okay? So really, this is what we're doing, right? Okay, so then I'm going to look at those pairs in isolation. So I'm thinking out of this first parentheses, do I have a common factor there? Yes, I do. I could factor out an x, but I could actually factor out x squared, right? I want to factor out as much as I can out of that. So then I would get, I'm thinking x squared times something equals 2x to the third. That would be 2x. And x squared times, a lot of times people will just do that and close the parentheses because they say, oh, I factored that out. Well, we need a 1 there as a placeholder. Think about distributing the x squared back in. You need to do x squared times 1 to get that term, right? Okay. Out of the second parentheses, I've got 8x and 4. Well, 4 goes into both of those. Okay, and then we've got this. Now, at this point, if you've got factors that are matching, you know you're on the right track. Okay. I'm going to take a break from this and do this problem over there, because when I give people this one, they'll say, oh, there's an a in both terms. I can factor out an a, and then I have x squared plus 4, right? And then I'd look at that. That's a sum of squares. I can't do anything more with that. It's the same idea over here, but it causes a bit of a problem for some people. So 2x plus 1 is think of this whole first part as its own term, and 2x plus 1 is a factor of that term. And the second term is this whole piece here, and 2x plus 1 is a factor of that. So I can factor 2x plus 1 out, okay? And then what's left over is x squared plus 4. So in other words, kind of thinking about distributing, okay? If I distributed the 2x plus 1 times x squared, it would be this, right? And yeah, you could actually distribute it, but it would look like that. And then 2x plus 1 times 4 is this piece, okay? So sometimes people get confused. There were two 2x plus 1s, now there's 1. Just like there were 2 a's here, and now there's 1, though. I'm just factoring those out, okay? The way I sometimes describe it, make a parentheses for what you have in common, what the common factor is, and then make a parentheses for the leftovers. What's, you know, in this case, the x squared plus 4. And then I check to see if there's any more factoring I can do. X squared plus 4. If that was x squared minus 4, I'd be in business with a difference of squares, but I can't do anything else with this. There's no more common factors, so there we go. So that is factoring by grouping, okay? There's another problem on the next page, which is the same kind of deal. It's a little trickier just because we've got this negative sign in the middle, and that will sometimes throw people off, okay? So what you don't want to do, this is what you don't want to do, and I'm going to erase this in a second, but this is what I see people do. This is not equivalent. It's okay to put the parentheses around those first two terms, but I can't do that because think about then distributing that negative in there would change the sign of that. So putting the parentheses like that is not equivalent to my original problem. So what I want to do instead, I want to always add my two groups together like I did in this previous problem, okay? So my first group is going to be 3x to the fourth plus 6x to the third. But then I want to add in the second group. So that means I'm going to put the negative with the 5. Okay, that is important. If you remember that, from there on out, it's kind of the same thing as the last problem. Okay, so in my first group, I'm thinking, oh, 3 goes into both of those, and I can take out x to the third as well. So I want to take out 3x to the third. And I'm thinking 3x to the third times something is 3x to the fourth, that would be x. 3x to the third times something is 6x to the third, that would be 2. Okay, in the second group, I could pull out a 5. That's true, you could pull that out. But if this first term is negative like it is here, pull the negative out with it. So I'm actually going to factor out a negative 5. Okay, so I got negative 5 times x is negative 5x, and negative 5 times 2 would be negative 10. Okay, and now if you just factor out a positive 5 instead, you wouldn't have these matching pieces like we do here. So then, you know, in that case, you could factor out a negative afterwards to get that to work out. Okay, but now we're ready to go. So I'm going to factor out the x plus 2. So in other words, making a parentheses for the parts they have in common. And then these are my leftovers, so I make a parentheses for 3x to the third minus 5. Then I'm checking if there's any more common factors here, or if this is a difference of squares, but it's not. 5's not a perfect square, neither is 3, neither is x to the third. So, there we go. Okay. So you can pause and try this one out if you like. I'm going to separate my two groups with a plus sign. So that means the negative should go in there with the 4. Okay, I can factor out x to the second out of my first group. And I can factor out negative 4 out of my second group. So negative 4 times x is negative 4x. Negative 4 times something is negative 20. That would be positive 5. And again, I've got the matching groups. It's possible you could have problems like this where it's just not factorable and it doesn't work with grouping. All the ones you're going to see for now are going to be set up so they do work. But just so you know, this isn't always going to work when you have 4 terms. Okay, so then I'm factoring out x plus 5. And then I've got x squared minus 4. And I'm done. Wait a second. I'm not done. There's more I can do. I've got a difference of squares here, right? So be on the lookout for that. Got 2 perfect squares and they're subtracted, so it's a difference. So this isn't completely factored until we take care of that difference of squares. And there we go. And that's it for today. And I'll continue on this section in the next video.